Hello, mathematicians. This is 8.2, Scientific Notation. So title your paper Scientific Notation. If you remember this from the past, scientific notation is written as the product of two factors in the form of a times 10 to the nth power. A has to be a number, if you notice here, between 1 and 10. 1 and 10 are included, but it can't be less than 1 and it can't be greater than 10. And 10 is not included. It can't be a double-digit number. So 9.999 works. So it has to be between a number between 1 and 10. So each number written in scientific notation. If not, explain. So if I look at this one, it is a no right off the bat because 56 is greater than 10. And this is a no because 0.84 is less than 1. This is yes because you have 6.11. So try A, B, and C. So A is a yes because it's 3.42. B is no. It should be 5.2, but it's 52 because of 52. And C is no because of 0.04. Sorry, I didn't write no. I'm sure you understand. Okay, write each number in scientific notation. So if you remember, if I have a large number, I'm going to start with my decimal point here, and I'm going to go backwards or forward, either way you look at it. Backwards, and I count the number of times I did that, my little bunny hops, and that's a 7. So it would be 5.69 times 10 to the 7th power. If my number is tiny, it's 9.875 times 10 to the negative 3. If it's a negative exponent, your number is going to be really small. If it's a positive exponent, your number is going to be quite large. So just try A, B, C, and D. So if I do A, I'm going to start here. I'm going to go 1, 2, 3, 4, 5. So it should be 2.67 times 10 to the 5th. B is 1, 2, 3, 4, 5, 6, 7. So it would be 4.6205 times 10 to the 7th. And then C is 1, 2, 3, 4, 5. So it would be 3.25 times 10 to the negative 5. And then D is 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 times 10 to the negative 9th. So for E it says you express 1 billion as 10 to the 9th. Explain why you express 436 billion as 4.36 times 10 to the 11th in scientific notation. So why would it change from 9 to 11? Well, if you look at this, 1 billion, so that's 1 million, so there's 1 billion. If I move my decimal point, 1, 2, 3, 4, 5, 6, 7, 8, 9, I have a number between 1 and 10, so that's pretty easy. 436 billion, you're going to have 436 out here, plus you're still going to have 9 zeros. So it bumps up to 11 as my exponent because I have these two spaces that I need to add to my 9. So I am going to still move the same 9 that I moved here, but then I have 2 more for the 3 and the 6. So it's going to go up to 11. So write each number in standard notation. So if you remember this, standard notation is I'm going to have a huge number and I want to just write it normal. Standard notation is standard, what everybody uses in the U.S. and everywhere. So 1,550,000 would look like this. And then 2 times 10 to the negative 11th is 0.000002. So try A, B, C, and D. Okay, so A, I'm going to start with 3.2 and I'm going to move it 12 times. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then I fill in my zeros. So then my number, if I go through and put in my commas, it would be 3 trillion. Is that right? 200 billion. So nobody wants to write out that enormous number, so that's why they choose to write it in scientific notation. 5.07, so I move it 4 times. 1, 2, 3, 4. This is pretty easy. It's 50,700. This is a -4, so I'm going to move backwards 1, 2, 3, 4, and my number gets smaller. So this answer is 0.00056. And then my last one, I'm just moving back twice, so it's 0.083. All right, so masses of planets. You can compare and order numbers in scientific notation. First, compare the powers of 10, and then compare the decimals. So it says, list the planets in order from least to greatest. So here's my 4 planets, Saturn, Neptune, Uranus, and Jupiter. And they give their masses. Now, you want to list them in order from greatest, least to greatest. So you're going to look at their exponents, so 25 goes first, and then you have 2 26s, so you compare them by looking at their number, and this is a 1 and this is a 5.7, so 1 is less than 5.7, and then this is a 27. So now they're ordered from the smallest to the largest. So try number 4. The following masses of parts of an atom are measured in grams. Order the parts of an atom from least to greatest masses. Okay, so my least is going to be my biggest number, but it's negative. So it'd be negative 9.1096 times 10 to the negative 28. They kind of try and throw you for a loop because in negative numbers, that's my smallest. If you think of a number line, negative 28 is the smallest number. And then, so that's an electron. That's the smallest. And then I have a proton and a neutron are about almost the exact same. However, the proton is a little bit smaller. They both have the same power, but they have a little bit, proton has a little bit smaller decimal point. So the proton comes next, and then the neutron. That's crazy to think it's that tiny. Okay, so using scientific notation to order numbers. Write each number in scientific notation first. So here they want you to order these from least to greatest, but they're kind of just all random numbers. Like this is not in scientific notation, and neither is this. So first they say write the numbers in scientific notation, and then arrange them by their powers. So if you look, these two are going to be the smaller ones, and 3.2 is smaller than 3.4, so they go first and second. And then these both have 5, but 5.12 is smaller than 5.2. So then it's pretty easy to order them. So try number 5. Order these from least to greatest. Okay, so for the first one, if I want to go back one more number, I am going to have to change my decimal, or my power. Now look at this. So 60.2, they want it -5. So 1, 2, 3, 4, 5. So the real number is 0.000602. So if I were to write this correctly, I would go 1, 2, 3, 4. So when it's a negative exponent, I'm going to rewrite it, and if I'm going to the left, I'm going to go up one number. So my actual scientific notation would be 6.02 times 10 to the -4. Now for this one, 63 times 10 to the 4th would be this, 63, I'm going to move it 4 times. So if I did this correctly, I would have to move it 5 times because I want it to be 6.3. So I'm going to add a whole nother move. So this one is 6.3 times 10 to the 5th. This I'm going to move 2 spaces to the right, and that's a, now this one's, yet again, it's a different instance. If I were to do this correctly, 0.067 times 10 to the 3rd, I'm going to make my number, it's really 67, okay? So what you're going to do is move this here, so it'd be 6.7 times 10. And then the last one is 61. So 61 is here, and I want to move it -2 times, so that means I'm going to make it smaller. So my number is 0.61. So 0.61 is my number, and I do this correctly, and I write it in scientific notation. I move it there, and it becomes 6.1 times 10 to the -1 power. So now you can order them from least to greatest. So my least number is the 6.1 times 10 to the -1. And then I have, oh no, sorry, I missed my -4. It's 6.02 times 10 to the -4, that's the first one. And then 6.1 times 10 to the -1, that's the second. And then 6.7 times 10, and then 6.3 times 10 to the 5th. That one takes a lot because you have to change each one of those separate problems. So simplify multiplying a number in scientific notation. So if they ask you to do 7 times this whole piece, you are going to, if you look at this, you're just multiplying the numbers that are in red. You're only multiplying what is in red. And so, because the scientific notation part, it's kind of funny, but that's just part of the number. This is really all one big number. They've just written it a different way. So when you do 7 times that big number, you just need to do the 7 times 4 and then add on the 10 to the 5th, because it's 5 zeros. And those 5 zeros are just going to add on anyway. So if I were to do A, I would just do 2.5 times 6, which is 15. And then I would have 10 to the 3rd. Now, this isn't in scientific notation. I have to move my decimal point to 1.5 times 10 to the 4th. So now this one, if I have 0.4 times 2, I get 0.8 times 10 to the -9th. And if you noticed here, when my number went from a bigger number to a smaller number, or here a bigger number, 15 to 1.5, I added an exponent. Here I'm going to 0.8. I need to move my decimal to 8. Okay, same thing here. I'm going from 0.6 to 6. I have to also add a negative exponent. So this went from 3 to 4. This goes from 9 to 10. -9 to -10. Because I want to go one more loop on when I move. All right, that's it for your note.